Hello, this is Caleb Captain, speech 4. My audience will introduce themselves now.
Hello, Rick Maiden.
Tam Wynn.
Esteban Garcia.
Elizabeth Guaype.
Richard Feynman was a theoretical physics, man-child, playboy, and very, very genius-level orator. He was not very much known for much else than being a troublemaker and going around and making everyone's lives a little bit less serious. But what he was a genius physicist able to take really complex ideas and break them down. I'm remembering Richard Feynman with speech 4 today because he's the person that I admire. As a mad scientist myself, I like to admire other people who have gone forward ahead of me and made everyone's lives a little bit better by introducing them to new concepts. With that, these are the sources that I used to make this speech. One quote from Goodreads.com, information about his Nobel Prize from the nobelprize.org, Caltech's library that has his speech on the Principia that Isaac Newton made, which used calculus, but Feynman explained it in simple high school geometry. Exploration from Goodreads.com, Feynman's contribution to the Manhattan Project from the nuclearsecrecy.com, Feynman's teaching philosophy from Quora.com, the video on Richard Feynman from YouTube, and another video of Feynman explaining various things from YouTube. Of the numerous geniuses that have walked amongst the earth and graced us with a little bit of more knowledge about how the universe functions, Feynman was one of the only ones who was able to take the complex things like quantum physics, quantum mechanics, quantum electrodynamics, and break them down into bite-sized chunks that we can all understand. With that, his ability to help us see things in a more simplistic light, his exceptional communication ability, and the role in using his knowledge that he had to better the world is why I honor Feynman today. Richard Feynman is noticeably famous for his Nobel Prize winning contribution called Feynman diagrams. Richard Feynman was an apt scientist and provided particle physics with a really great graphical way to expand upon the unseen. Quantum anything, quantum thermodynamics, quantum electrodynamics, quantum nuclear physics wasn't really that big whenever Feynman was a physicist, but what he did is he broke it down into a graphical interface and math sort of writing style that was called Feynman diagrams. While they're normally simple looking diagrams, they actually hold a lot of math behind them, and they're very much able to show everyone in the world how an electron or a photon or how other subatomic particles would react whenever they pass by each other, whenever they collide, or whenever they're doing nuclear fission. Another thing about Feynman diagrams is that they gave him the Nobel Prize in 1965. He only got 1/3 of the prize in physics, but the one thing that was very important about Feynman diagrams is that they're used all over the world today, and they're very important in subatomic particle studies. Feynman's diagrams are a chief showing of how Feynman took very complex ideas and broke them down into things that everyone in the world can understand. But along with being able to break them down for other scientists to understand in a laboratory, he was able to do the exact same thing with other topics in the classroom to students. Feynman did do lots of experiments in the laboratory, but in the professor side of Feynman, he was one of the chief professors at Caltech University that taught his students various things that are complex and broke them down into simplistic bite-sized information. In the video, Fun to Imagine, Feynman was shown explaining to us various things from magnetics to how rubber bands works to how the universe in astronomy works, and he took it in very simplistic terms. He used things like strings instead of polymers that are attached in chains to describe rubber bands, and instead of using electrodynamics and magnets, he used words like attraction and want and don't want, things like that to help everyone in the world, and even his students at Caltech, understand how the world around them worked. Another thing that Richard Feynman is very well known for is that his lost lectures on the Principia that Isaac Newton had done completely in calculus, Feynman took and broke down the entire movement of the celestial bodies and elliptical orbits in high school geometry, something that all of his students in Caltech could understand easily and could prove just as easily using math that they had learned 4 years ago. Another thing about Feynman is that his teaching philosophy was that if he couldn't reduce it to something simple to teach other people, then he didn't feel like he knew it. And my mom being a high school chemistry teacher for 9 years, I sort of accepted that same philosophy. If you can't explain it to someone or teach it to them in a way that's easy for them to understand, then I don't believe you truly knew things. And that's what Feynman embodied in his teaching style and his philosophies on how he taught his students. Finally, Feynman was an intelligent science professor, but also he was intelligent enough to know when the world needed his intelligence and needed his help on various things, which is how he got involved in the Manhattan Project. Richard Feynman was one of the physicists who worked on the Manhattan Project. The best of the best in particle physics, nuclear engineering, and all sorts of other scientific studies were taken by the US military to create the first atomic weapons. Now, Feynman was still in college whenever he joined the Manhattan Project, but the very important thing about Feynman is that he was very useful in figuring out how much uranium was needed to make an atomic explosion. And with that, Feynman was one of the only people who was really far gone in the field of nuclear engineering at the time. Another thing that was very useful about Feynman is that even during the Manhattan Project, while he caused lots of troubles by going about on the town and making trouble going to strip clubs and playing the bongos and messing with other scientists on the reservation, what he was also known for is being the it guy whenever it came to safety regulations on how purified uranium should be contained. Not only was he there to create the explosions that would be used to kill many people, but he was also there to make sure that the people at the reservation were safe. Due to uranium being a very toxic and harmful substance, he was able to make the calculations of how much water was needed to purify it and what sort of containers the uranium would need to be in. Richard Feynman was one of the greatest explainers in physics that has ever graced us with his knowledge. While being a man-child, troublemaker, and exceptionally a ladies' man, he was definitely one of the people that I look up to simply because he was able to explain all the important and hard-to-answer questions in a childlike manner that none of us can do regularly. In conclusion, Richard Feynman helped particle physics with the creation of Feynman diagrams and pushed us forward in the field of quantum electrodynamics. Richard Feynman also helped raise and better inform the future generation of scientists. He inspired many like Neil deGrasse Tyson and Sir Robert Krauss. And also, finally, Richard Feynman helped create I would arguably say a better world, but he was always there to help no matter what the situation had asked for. Now that you know more about Richard Feynman and why I admire him, hopefully maybe one day you'll be able to share a bit of this information with your own friends and maybe, just maybe, go on to do some particle physics work.